All right, so we're in section 4.3 today. All right, so the first thing that I want to say or want to point out is that we cannot use angle, angle, angle. To show that triangles are congruent. And let me draw a picture to show us why. There's a triangle with three particular angles. And there's another triangle with the same three angles. And those two triangles are not congruent. They have the same angles, but they're not congruent. So physical representation. So the triangles, the big triangle and the triangle in the middle, they both have the same angles, but they're not congruent. We can have an infinite number of triangles with the same three angles that are different sizes. So we cannot use angle, angle, angle to show that triangles are congruent. Sometimes it's very tempting, but we can't use angle, angle, angle. All right. So a couple more ways that we can show that triangles are congruent, though. We're going to talk about the ASA postulate. ASA means Angleside angle. So what we're going to say for the Angleside angle, very similar to side angle side. But we're going to say if two angles and the included side and again, included means between, of one triangle are congruent to two angles and the included side of another triangle. Oops, not congruent, another triangle. Then the triangles are congruent. So, picture. We would have something like this. So we'd mark our triangle with these parts, and this side in between these two angles is the included side. And I'm going to mark this triangle like so. And I'll call this A, B, C, and D, E, F. And our congruent statement, we would say triangle ABC is congruent to triangle. Well, A has to match up with angle F. B has to match up with angle D. And C has to match up with angle E. So triangle ABC would be congruent to triangle FDE. And this tells us that side AB is congruent to side FD, AB, congruent to side FD. So our parts match up the way they need to. And again, the way that we talk about them in the triangle, angle, side, angle, they go in the same order as it says in the postulate or the theorem. So we can read the parts along the triangle the same way we read them along here. Angle, side, angle. And again, we need 3 parts for all of our postulates and theorems so far. We need 3 things to show that triangles are congruent. And that'll be true for all of them. There's one that's kind of an exception, but really it is still 3 things. All right, so questions on that postulate? Okay, let's look at the angle-side triangle. So I'm going to draw a specific triangle here, 2 of them, and we're going to take a look at these. So I'm going to say this is 60 degrees, this is 75 degrees, and we have this, and we have the same angles in this triangle. All right, so if we have these 2 angles, a 60-degree angle and a 75-degree angle there, and a 60-degree and a 75 there, what do we know about these third angles? They have to be congruent, right? We talked about the third angle theorem. Well, we could also figure it out by saying, well, all 3 of these angles have to add up to 180. All 3 of these have to add up to 180. Well, whatever I add to these 2 to get 180 is exactly the same as that what I add to these 2 to get 180. So these 2 angles have to be congruent. So now we have, instead of an angle-side triangle, we have an angle-side angle. Angle-side angle. So we've turned the angle-side triangle into an angle-side angle triangle because the third angles have to be congruent. So our third angles are congruent, and now we have ASA. So angle-side really, as long as all the parts match up the right way, is the same as angle-side angle. So that's what lets us use angle-side. So let's write our theorem. This is going to be the angle-side theorem because we figured it out from the angle-side angle postulate. Our angle-side theorem tells us if 2 angles and a non-included side of one triangle are congruent to the corresponding side and angles of another triangle, then the triangles are congruent. And the reason that we say corresponding is that the parts have to match up in the right order. So that's why we say corresponding. We have to make sure the parts match up in the right order. So our picture for an angle-angle-side triangle would look something like this. And I would call this A, B, C, and D, E, F. And for my congruent statement, I'd say triangle ABC is congruent to A matches up with angle D, B matches up with angle E, and then side BC matches up with EF. And our parts are all in the right order. And what I mean by that is the 2 tick mark side is next to the 2 tick mark angle. The 2 tick mark side is next to the 2 tick mark angle. If one of these 2 tick mark sides was down here, that would be in the wrong order. They wouldn't match up in the same order. So this is what we call an angle-angle side. All right, questions? Okay, what I want to do is go through a few examples where I just draw triangles and we want to decide, can we use angle-angle side? So we want to figure out, do the parts match up in the right order? So I'm going to say, can we use angle-angle side for all of these? So here are my triangles for the first one. Can we use angle-angle side on those 2 triangles? Do the corresponding parts match? Do they match up in the same order? The 1 tick mark side here is next to the 2 tick mark angle. The 1 tick mark side here is next to the 2 tick mark angle. So everything matches in the right order. So we would say yes, we can use angle-angle side. So let's look at this one. Oops. How about those 2? So we have 1 tick mark, 2 tick marks, and then a 2 tick mark side. 1 tick mark, 2 tick marks, and then a blank, and then the 2 tick mark side. Or the other way we could look at it is the 2 tick mark side here is next to the 2 tick mark angle. 2 tick mark side here is next to the 1 tick mark angle. So this would be no, they don't match up in the right order. So we can't use angle-angle side. How about this one? Oops, that's not what I wanted to do. Do this. How about that one? They match up in the right order? Yeah. The 1 tick mark side is next to the 2 tick mark angle, 1 tick mark side, 2 tick mark angle. In order to get these triangles to match each other, I'd have to flip that one over. Where here I could just slide them over. Here I'd have to flip it over. So this would be a yes. We could use angle-angle side. Last one of these, and then we'll do a quick proof that has to do with angle-angle side. whoops, and this should be, there should be 2 there. How about that one? No? Yes? Maybe? Two tick mark side is next to the 1 tick mark angle here. The 2 tick mark side here is next to the 2 tick mark angle there. So that would be a no, not the right order. So that's when the theorem says the corresponding, that's what it means, but that's what the corresponding means. We have to match them up in the right order. All right, questions on the example? Okay, I want to go through a quick proof, and then we will be done for today. We'll answer questions on homework, and then we'll do some whiteboard practice. And this proof shows some of the things like I was talking about with the opener. All right, so before I go any further, what do the 2 arrows on those 2 segments mean? It means they're parallel. All right, so I'm going to mark these congruent, and I'll label the sides for the vertices A, B, C, and D. And we're going to be given, so given is just what's marked here, angle ADC is congruent to angle CBA. So that angle and that angle. And that segment AB is parallel to segment DC. We want to prove that triangle ADC is congruent to triangle CBA. All right, so we'll do a 2-column proof with our statements and our reasons. And I'm not going to rewrite all the givens. So I'm just going to say that is all given. All right, well, we know we need 3 pieces of information. All of our theorems or postulates for congruent triangles have 3 pieces of information. All we have right now is that 1 angle in this triangle is congruent to 1 angle in that triangle. So we need to figure some other stuff out. So what can we figure out? So, yeah? Okay, very nice. Those angles are congruent because these two segments are parallel. This is our transversal, so those are alternate interior angles. So we'd say angle BAC is congruent to angle DCA. And our reason would be alternate interior. All right, so there's 2 pieces of information. We have 2 angles. Another thing so that's where parallel lines, that's the information for parallel lines keeps coming back. We keep needing to use that. When we see 2 triangles that are joined together here, that's a clue that you're going to need a specific thing there. So what do we know about segment AC on the left triangle and segment AC on the right triangle? They're congruent. It's the same segment, right? So that is congruent to itself. Segment AC is congruent to segment AC. And do you remember that reason? Yeah? Reflexive. That comes up a lot when we're talking about triangles, the reflexive property. Well, now we have angle, angle, side, and angle, angle, side. The 3 tick mark side is next to the 2 tick mark angle. 3 tick mark side next to the 2 tick mark angle. They match up in the right order. So we can say triangle ADC is congruent to triangle And angle A has to match up with angle C. C, B, A. And that would be angle, angle, side. So this part of what we do in chapter 4 is show that triangles are congruent. This is an example of how we go about that. All right, so questions on the example or on the proof? Okay.